get into programming lessons where there's a lot of fiddly details with like the actual programming. And if we fly through and you miss something and it doesn't work, you can go back and watch the videos. It's more useful than if we did it for like the internet simulator lessons. Those didn't really have a lot to offer, or replays of those would not have had a lot to offer. Okay, so lesson 4, okay, using simple commands is 7th period. No, 7th period. 5 should still be invisible to you guys. Okay, so using simple commands, we are getting into the app lab. There is an introductory video called You Should Learn to Code, which I have put here in our slides of videos. We're not going to watch it. Having watched it many times, it's getting kind of old. It's not completely useless, but it is like 10 minutes, and there's probably like 2 to 3 useful minutes. Feel free to watch it on your own time. It might be, or when we're done here, but I'm not going to stop everything and have us watch it. It should be linked. Oh, it's not even linked in this one. It's linked. This is from, okay, yeah. So we haven't even talked about why we're jumping to lesson 4. Okay, the reason why we are not doing lessons 1, 2, and 3. Lesson 1 is just an introductory lesson for the unit, just like the other lesson 1s that are a lot of here's the general idea plus some check for understandings that are really like, what's your experience with coding, or what do you expect, that sort of thing. Kind of a waste of time, definitely not very interesting. And the other 2 are about algorithms, which algorithm is this general term for any sort of complex equation. You've probably heard the term algorithm before, and it's used in many different ways, but these first 2 lessons are offline lessons with some worksheets and not very interesting, and I'm really champing at the bit to get to programming, so that's what we're going to do. Okay, so we are jumping right into lesson 4, which again, I still get questions about where is whichever lesson. If you don't see a lesson where it's not an assignment. Okay. All right, so we're going to jump right into lesson 4. We have the overview here on bubble 1 with some general concepts or advice. And we're not going to be doing pair programming. We're going to be doing things solo. That doesn't mean you are not barred from consulting, but with each other. But this is not going to be team projects really at any point. And let us watch the introduction video for this lesson, where we will learn about turtle programming. I will put videos that you otherwise are not likely to be able to get to from Chromebooks because of the YouTube restriction. I'll put those in our slides under info video for whichever lesson we're working on. But if you are able to get to it from a bubble, like bubble 2 is this video, I don't think you have any issues with it. So I'm not going to post those videos, but here you go. Please enjoy it.
My name is Jasmine, I'm 26 years old, and I'm a software development engineer. I think what I really like about programming is that it helps me solve problems that I was able to solve on my own. Especially as someone who's dyslexic, I like the fact that programming allows me to repeat something over and over again, and I don't have to worry about spelling without the line.
You should worry about spelling.
A programming language is a coding language that's used to dictate specific instructions to a computer. Just like there are thousands of human languages that are used to communicate amongst humans, there are hundreds of different programming languages that have been created for humans to communicate with computers. The language you use will often depend on what you're trying to do, but nearly all programming languages are equivalent in terms of being able to express. Programming environment is a formal term for a tool which you use to write and run computer programs. In this class, you'll be learning the programming language JavaScript. This language is widely used to make interactive websites and mobile apps. The programming environment you'll be using is called AppLab. AppLab was designed with new JavaScript programming. Although it was made for novices, there's many powerful features, which makes creating shareable mobile applications fast and easy. We will start by learning to program using a virtual robot called the Turtle. In AppLab, the turtle looks like this. Now, I know what you're thinking. Why are we learning to program with a turtle? And why does it look nothing like an actual turtle? Historically, the turtle has been one of the more popular ways to learn to program. But originally, it was an actual robot. Students could program it to move and turn while the robot dragged a pen on the floor. This would create simple drawings. The original robot was actually domed in shape, which made it kind of look like a turtle and similar. As graphics technology improved, turtle programming migrated to the computer. Here, the turtle was sometimes depicted as a little turtle, but often just an arrow. Turtle programming is a powerful metaphor for programming. Starting with simple commands, you can build up to some very sophisticated behavior. The programming and problem-solving techniques you'll learn using the turtle will apply every time you're going to solve a problem code. This applies whether you're building a game, designing a mobile application, or creating a simulation. So let's get started. Initially, you'll have to solve problems only with a very small set of commands. In fact, you'll have to do everything with only move forward, turn left, and up, and then down. In AppLab, here's how you add lines of code. You can drag blocks from the toolbox and snap them together. Then click Run to see your code in action. Or, if you prefer, you can type the commands in yourself. Either way you write code, you can always flip between block mode and text mode. In fact, you can work in text mode and drag the blocks out to insert more text. If you want to practice typing code, that's awesome. If you make an error, you can use the blocks to check the correct way to enter code. If you want to get rid of a line of code, that's easy too. Just drag it off the screen or delete the line of text. Learning a programming language with a turtle is fun and can require a significant amount of creativity. Even if you've programmed in a similar way before, you'll probably find this simple-looking turtle composing fun and challenging puzzles. As we develop our JavaScript programming skills, we'll eventually leave the turtle behind.
All right, go ahead and hop on to lesson 4, go straight to bubble 3. And even if you have done this from Friday, still follow along with us. Okay, so a couple of major pieces of advice. First of all, this is a strong recommendation. I'll try to be clear between recommendation and demands. Strong recommendation, use full screen when you're in AppLab. Okay, if you have function keys on the keyboard you're using, it's F11. You can also find it through the Chrome menus. Full screen right there. Okay, you are limited in the pixels you can use. And later on, when we get to longer codes, it will help you. Longer programs, it will help you. Some other things that you may not have been aware about or aware of are the, okay, so the default is working in blocks. You can also work in text. We showed that. There are some times where it is actually significantly easier to work in text. Later on, when we start doing conditionals, where you have to do sort of order of operation things, AppLab will try to guess where the parentheses go, but as you know, parentheses in the wrong place will make it be something completely different. Did I hit insert? So those are times, and I'll remind you. Other things that might be useful are white space. So white space is the programming term for just blank lines. And if you leave some blanks in there, you can then use that to organize. I will almost always do that because my eyes start to blur when you get to too many lines in the row. The other thing you have access to, which even though they don't have the tab for it, is what's called comments, where 2 slashes and then anything is a comment, okay, which allows you to write notes to yourself or to yourself in the future or somebody else that might be working with you, okay? You know, either describing what that chunk of code is supposed to do to give yourself a chance to debug it in the future, or the like what needs to still happen in this certain area, just a place to write things. The other thing that comments do are that, okay, so if I have a move forward, turn left, move forward, turn left, you can do what's called commenting out. And commenting out, stop this, is same thing as you would call deactivating. So if you were trying to debug something, you could comment out lines of code and test what it would do without those lines of code, as opposed to deleting them. You can also do control slash is the same thing as comment out, but we'll get to that in a second or at some point. All right, so other things will show up or come up as we go. Let's try and solve these simple problems. Okay, so we need to draw a square to the front and left. That is a forward, left, forward, left, forward, left, forward, left. So it's forward, left, and we can just copy this 3 more times, and there you go. A few people were not able to, I've seen people solving or working on like the second or third puzzle here and trying to do it with the turtle pace and just like watching it like it's trying to compile, you know, pages and pages of code. There's a speed bar down here. Should be pretty self-evident with the turtle and hare situation. As we get further along, you're just going to have it all the way up so that stuff happens instantly. There's no reason to wait around for it, but having it a notch or two, even though there's no notches, a smidge down will help you see what's actually happening while it's happening. Super useful. All right, so where were we? We had a forward, left, 1, 2, 3, 4. Is that where we left it? 1, 2, 3, 4. Good enough. Okay. And leaving it where it starts is the part of the key for this. Okay, when you are done anytime in these App Lab puzzles, go and run and then finish. And there are times when it will actually check for some criteria that you could do, you know, to see that you did it correctly. In the past, it's just been like, are you sure you're done with this? Hit continue, and it would let you move on. But here we'll actually check for something, so you should do that. Okay, so here we have the similar puzzle, except we want the square to be to the forward and right, and we are not given a right turn command. So a couple ways to solve this. Only one of them is technically right. And that is 3 lefts in this current context is equal to a right. So you may have solved this before on your own if you have been driving in a city with a lot of one-way streets and you need to take a left, going up and taking a right, another right and another right will leave you pointing what would have been left. So 3 lefts in this case is a right, and doing this a total of 4 times, assuming I did it right, will get us there. Now, the other ways to do this that are not as good, let's see if it will let us do type in turn right. Yeah, okay. So it does not have, you do not have access to turn right at this point. Okay. The other way that people may have solved is by using the parameters, which are, or adding a parameter. In a function, every function will end with an open close parentheses. That is what defines it as a function, or that's what lets the program know this word is a function. Now, if most of the time, I shouldn't say most of the time, a lot of the time it will be blank, but you will write functions that are receiving what's called parameters. In this case, we could, in theory, make a 270-degree left turn, which will have it point to the right. You could also have it make a negative 90-degree left turn. Same thing. Okay. And did anybody try this? Anybody get to this point? Okay. So if you do this, and we just need to do this 4 times, it will be correct. But if you hit finish, it will say that you're being too clever. Stop it. Okay. Which is what this is saying. Yeah, you discovered something. Don't. Okay. Although this is the point is to force you to think about, to solve problems differently, not just learn how to enter program code, which, yes, entering program code is good, but thinking about solving a problem with limited tools is sort of the point. Okay, and bubble 5, and then the checks for understanding. I'll give you a minute to do the checks for understanding. Okay, so the bubble 5 is draw a 3x3 grid, and the lowest, let's see, oh, here's something you may not be aware of. Version history will let you get back to a number of autosaves for your puzzle. And you can also do start over, which will clear out the puzzle, or at least put it back to whatever you started with. Like in some of the puzzles, it'll start with a small chunk. Start over will take you back there, and it won't clear out. You'll still have access to your version history, so it doesn't like completely wipe it. But yeah, so that's useful. All right, so let's see, which one is this? It'd be nice if there was. Okay, so I think the logical way to solve this is to do this in steps, where you are creating a single square, okay, and using that to make a row of squares, and using that to make 3 rows of squares. Now, based on the fact that we don't have access to a turn right, if you start out with a triple left, you'll be facing due east, and then you can solve all of the squares and rows of rows using left turns, going around everything counterclockwise. So you only have to do 1 right turn instead of a right turn at every corner. Okay, and I'm pretty sure that's what this one does. Let me make sure. Yeah. Okay, so it's just about, like I said, solving 1 square, but it's 1 square plus a move forward, so that you are able to do, let's go all the way down to the bottom. Okay, so you have, how far are we go? Okay, so you have 1 square, but if we did that again, it would just draw over it again. So we need another move forward so that it's ready for another square. Okay, and all the way, so on, all the way through is this the end of the row? Okay, so the end of the row, if you just did the same thing 3 times, would put you Is this the last? No, this is the sort of reset. Yeah. Okay, so if you're doing it this way, it would leave you with like here, and then you have to do a small chunk to get back to the beginning so that you can just copy everything you have up to this point twice more, because this one ends right here facing due east. That's where our row essentially started from. Okay, I would call this the most logical way to solve this, and probably the most useful way in terms of where we are headed with functions. We'll talk about functions in the next lesson. The record, and let's see if we can find one. The record for fewest number of lines of code, I believe, is 44. And let's see if this is that one. Yeah. Okay, so in 44 lines of code, this is possible. I don't expect anyone to have come up with this. This took a long time, a lot of people to refine. I mean, if you did, great. But the pattern would be something like this, or no, would be something like this. It still starts out with a triple left, but yeah, so I would not take points off if you did that, or if you were not able to do this. In fact, you can tell where it's been drawn twice. Like the ink is the trail is a little bit darker. And it's also where it's darker on this one, I think. Although not necessarily. But there you go. There's that. Okay, so checks for understanding for lesson 4. Let's take a look at them and give me a second to hide the answers. That one. That one. And this one. Okay, lesson 4, checks for understanding, bubble 6. Okay, lesson, we introduced the notion of efficiency in programming and what that means, different things, different times. Think of an example outside computer science in which you've heard the term efficiency, compare it to the ways we talked about efficiency in programming. What's the meaning of efficiency and how is it same or different? Okay, and say we solve a problem, limited series of commands. Give at least one reason why it's useful to learn how to solve problems with a limited set of commands. We definitely discussed that. Okay, in the lesson, draw squares. Briefly describe the code, drawing a rectangle and how that'd be different than drawing a square. You don't have to overanalyze it, just what would actually happen. And finally, summarize your experience. What surprised you about programming such a small set of commands? Were you able to be creative with such a limited set of tools? And what was most frustrating about the activity? If you could add a simple command, what would it be and why? Okay, so I'll give you a few minutes to wrap this up and then we'll start lesson 5.